All right, hey Jalen, this is section 7.4. We're going to talk some things that we've done in the past before we get to the actual section here. So, before we talked about two triangles being congruent, okay? And I'm going to draw a picture off to the side here of what this looks like. Here's my two triangles that I'm trying to prove are the same shape, same size, okay? This is congruent, not similar. We'll get to that here in a second. But two triangles are same shape, same shape, same size. And one of the ways that we can do that is by proving that all three sides are the same length. You remember that? Side, side, side? Okay? So I want to be able to say, like, this side is the same as this one, this side's the same as this one, and this side's the same as that one. And if I do that, I don't even have to look at the angles. I can just say, by side, 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 those two triangles have to be exactly the same, 100%. Okay? We're going to have a side, side, side thing for similar triangles, but it looks a little bit different. So I'll show you that here in a second. But let's talk about the other ways. So what's another thing that I could do for two triangles to make sure that they're congruent? Side angle side. Okay, so in my two triangles, I'll try to draw a little bit smaller here. In my two triangles, if I say this side is the same as this one, this angle is the same as this one, and this side is the same as this one, then those two triangles have to be the same shape, same size. I don't even have to look at the third side or the other two angles because they have to be the same. So side angle side, they are congruent 100%, no way around it. Okay, what's another thing that I can do? There's two more.
Angle, angle, angle.
What? Angle, angle. What? Angle, angle.
Side.
We have to have a side, right? Angle, angle side is another way. Have you had these before, Evan? Yeah. Angle, angle side is one of them. Okay, so Good. Okay, so angle, angle, side. So if I do that, the side is not in between the two angles, okay? So we have this angle, just for example, and then the side would be the bottom side, right? So angle, angle, side, that would be an example of an angle, angle, side. And then there's one more. Oh, isn't it? Should I write it up there?
No.
No?
Angle, side, no.
Angle, side. No, does not work, right? You remember that because you remember that it's a naughty word, right? So it doesn't work. And in the same way, side, angle does not work, right? Because that's ASS backwards, right?
Yeah.
That's so funny. All right, anyway, okay, keep going. What else we got? One more method. Angle, angle, angle is not one. What? Angle, side, angle, that's the missing one. ASA, we've got, in this case, this is different than angle, angle, side because the side has to be between the two angles. So we've got, wait a second. Okay, here we go. We've got, I can't. Okay, here we go. We've got an angle, let's do the top angle, side, angle. And angle, side, angle. So we've got that going on. And as long as we have that going on, we don't even have to look at the other angle or the two other sides. We know that those have to be congruent, right? Okay. All right, that was a long intro. Now we're going to talk about similar, okay? So if we're trying to prove that triangles are similar to each other, again, that's same shape but different size, we have two things that we're learning today that will do that for us, and one of them is side, side, side. Okay, and this is what side, side, side says. Here's this triangle, and I want to prove that he is similar to, like, this triangle, right? Okay, same shape but different size. Okay, side, side, side doesn't mean that I'm looking at the lengths of the sides being the same. Here's what side, side, side says. So what I'm going to do is, like, let's say this is A, B, C, and D, E, F, right? The way I prove side, side, side is saying that side AB over side DE is going to be the same as BC over EF, which is the same as CA over D or over FD, right? So the proportions are the same. The ratios are the same. So I'm going to do ratios over here. It's not looking at the lengths themselves. It's looking at the ratios, okay? So I'm going to give some examples in here. Let's say that this is a 3, this is a 6. I'll just do really easy examples. This is a 5, this is a 10, this is a 4, this is an 8. Technically, that's a right triangle, but whatever, it's fine. And if we do those ratios, like AB to DE would be 3 over 6. That is the same thing as 5 over 10, which is the same thing as 4 over 8. So we're doing side, 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 but we're not looking at the lengths being the same. We're looking at the proportions being the same. Does that make sense? Mm-hmm. Yeah? Okay. So that's kind of how side, side, side for similar triangles works, right? Not looking at lengths being exactly the same, but the proportions, okay? And then we have one other one that we're going to talk about today, so I'll just do it here. This is side, angle, side, which we did have for congruent, okay? But side, side, side looks a little bit different, okay? Let's say I have this guy going on here and this guy going on here, okay? So I'm going to say this is 3, this is 6, this is 4, and this is 8, okay? So I have the two sides, right? And I have 3 in comparison to 6 is the same thing as 4 in comparison to 8, right? Okay? But then I have the angle that's in between them having to be the same, okay? So this angle right here and this angle right here, it does not mean that like if this is 40 degrees, then this is 80 degrees. It's not double also. We learned that yesterday, right? The angle will be exactly the same measure. So if that one's 40, this one is also 40, okay? So when you're doing side, angle, side, these two guys will have the same proportion or the same ratios, ratios. The angle will be exactly the same. I'm going to do congruent. The angles will be congruent. So the congruent angle in the middle and the two sides are proportionate, right? So that's kind of how side, angle, side works. Okay. Good, good. All right, moving on. Let's do some examples. We'll skip some of these boxes to make it go faster. Can I go? Can I go?
Yeah.
Can I go? Let's go. Okay, A and B, they're saying determine whether they are similar or not. If so, write a similarity statement, blah, blah, blah. Okay, A. They want us to do this by side, side, side. Okay, technically on A, we could do side, angle, side, right?
Yeah.
What angle do they have that are the same?
The vertical angle.
The vertical angles. This one and this one have to be the same because they're vertical angles, right? So we could do side, angle, side if we wanted to, but they want us to do it by side, side, side. So we're going to look at the sides and we're going to look at the proportions. So this over this has to be equal to this over this, which is equal to this over this. And we're going to reduce them and figure out what they are, and then we're going to, whatever. Okay? So let's start. What side over what side? 6 over 15. That's a good place to start. Next one. 5 over 12.5. And next? 8 over 20, right? Because those are kind of like rotated a little bit, okay? So if we reduce those, 6 and 15, I think that's like 2/5 or 0.4. 5 divided by 12.5, if you do it in your calculator, I'm going to give you a little hint, it's 0.4. 8 divided by 20, if you do it, is also 0.4, okay? We were trying to do these in our heads this morning, first period, which was kind of exciting. Kind of. And a way of doing this in your head, you want to go out of 100. So if I take 20 times 5, that number will be 100. 8 times 5 is 40. What's 40 hundredths? 40 hundredths, right? Okay, same thing here. 12 and a half times 2 is 25. 25. And this would be 10. So 10 25ths. Or then you can take 25 times 4. So this would be 100. And this would be 40. Make sense? So 40 hundredths. So you can do that in your head or by just multiplying by the same number to get those values. So 0.4, 0.4, 0.4, that means that he is, yes, a similar triangle. And now that we just have to write which ones go together. So triangle whatever is similar to triangle whatever, and let's list them in order. How do you want to go?
PQR.
P, Q, R, okay. P goes with S, is that right? P goes with S, okay. STR, yep. PQR, STR. That is one way of labeling it. That will work. Okay, good? All right, let's go to B. We're doing side, side, side again, so we got to do the ratios. So something over something, something over something, something over something. Okay, what do you want to start? 1.8 over 2.4. I think those go together, yep. Okay. 2.7, 3.5, and 3.6, 4.4. Okay. All right. 1.8, 2.4. I don't know. 1.8, 2.4 is 0.75. 2.7, 3.5 is 0.77-ish. At this point, he's already a fail, so I don't know why I'm still going, but anyway, whatever. 0.82. Not going to work. Not similar triangles. They have to be exactly the same. These are close, but they have to be exactly the same, so no. not similar. Okay? Good? Happy with that? All the sides have to be the same proportion. Oh, dang it, there's a graph. You're gonna hate this example. I'm not gonna lie to you. You're gonna not like it very much. But let's graph them. So we've got A, B, C. Let's plot them. -2, 1. Or maybe you'll just really like go nuts and love this. I don't know. Maybe. But I feel like I know you well enough to say that you're not gonna like this very much. B is 3, -1. You don't have to label the coordinate points. I'm gonna do it just because it makes it easier here in a second. C is 1, 4. Okay. All right. I'm going to use a different color now. You don't have to use a different color, but I am to make it easier. And here we go. I know. I missed one. 2, -6, 4, 6. Y. Okay. Here we go.
Oh boy.
Ew. I don't like it when you do.
All right. Okay. Good? We got them all plotted? All right. We want to look at each one of the sides.
I've had enough of this. Do we
Libby?
have to do the distance that many times?
Yeah.
Serious?
Yep, we do. We do. 6 of them. So we're doing side to side, right? We're looking at all 3 sides.
This is what Jalen is good at. Why can't she
I
be
know.
here?
Jalen, we miss
Yeah,
you.
Jalen, come back. I
Okay.
miss you.
All right, so side to side. I'm gonna do it this way. Okay, set them up this way because I have a method to my madness. One of the sides is AC. Let's do that one. Okay, and we got the square root of all that good stuff. Another side is CB, and we got square root stuff. And another side is BA, and we got square root stuff. So I'm writing them out like this, and there's a reason why I'm doing that. So just FYI. My other one, which side goes with AC? Just so we can be in order.
Oh, ZY?
I think it's ZX. AC, look at my diagram. AC goes with ZX.
Oh, yeah.
Is that right?
Yeah.
Okay. All right, so ZX. Come on. CB goes with XY, yep.
And then YZ.
And YZ is the other one. Okay.
How many of these are we gonna have to do our homework?
I don't know. I don't think it may be. I don't know. All right, we've got plus and square and plus and square and plus and square. I told him this morning I feel like I'm an exercise coach or something. And plus and square and plus and square. Okay, anyway. All right, distance formula. Here we go. Ready?
Sure.
Okay. AC, from A to C, we're looking at the x's. So -2 to 1. How many were going in the x direction? 3, how many going from 1 to 4? 3, so we got 3's and 3's. And so we go to A, 3 squared, 9, and 9, and that's the square root of 18. We're going to leave it. Okay? One and done. One done. Not one and done. One done.
I wish.
I know, right? One done. Okay? CB. From C to B, we're going 1 to 3. How far? 2. From, I can't even see my top number, 4 to -1. 5. So what did I say? 2 and 5? 2 squared. 5 squared. So 4 and 25. The square root of 29 is what he will be. Okay? B to A. Is this making sense, Evan?
Yeah.
We're doing distance formula and we cheat so bad. We don't write it all out. We just do distance. We just go fast, right? Okay, so -2 to 3, 5, 1 to -1, 2. So we got 5's and 2's, right? 5 squared is 25, 2 squared is 4, square root of 29 again. Ooh, that is an isosceles triangle. Whoa, whoa. Okay, ZX. Now let's do the red ones. Okay, so Z to X. -8 to negative 2. 6. Negative 2 to 4.
2. Negative 2 to 4?
Negative 2 to positive 4.
Positive 4. 6.
6. So we got 6s. 6, 6, 36, 36, square root of 72. Okay? Good? YZ now. YZ is the side ones. So we're going negative 2 to 2. 4. 4 to negative 6. 4 to negative 6 right here. 4, negative 6. 10. So we got 4s and 10s. 4 squared. Whoa, wait a second. 4 squared, 10 squared, 16 and 100. So that's the square root of 116. Okay. YZ. What do you think it is? No?
I don't.
YZ? This guy up top here was an isosceles triangle. I'm going to guess that's 116 also, right? Yeah. So the next one. All right, negative 8 to 2 is 10 again. Negative 2 to 6, or to negative 6 is 4. So we get 10s and 4s again, which is the square root of 116. Yeah? Makes sense? Okay, now. We're not done yet. Okay? Oh my gosh, we're not done yet. Because we have to look at the proportions. So we have the square root of 18 over the square root of 72 is equal to the square root of 29 over the square root of 116, which is equal to the square root of 29 over the square root of 116. We really only have to check the first two, right? Because the third one is the same. But Luke said this morning, which was kind of brilliant, he said, wait a second, if they're all square roots, won't it be the same if we just take the square roots off, right? 18 over 72 has to be the same as 29 over 116. Yeah, you're right. So you can take the square, if they're all under square roots, we can take the square roots off and just check the numbers underneath. So 18 divided by 72 is 0.25 if you do it in your calculator, or it's 1/4. 29 divided by 116 is also 0.25. And then, of course, the last one is 0.25 as well. Okay? So,
Cool.
what's that be?
It's similar.
Yes! Oh, boy, we finally get it. Yes, they are similar. Right? Oh, that's right. This guy is similar to this guy. We're gonna skip the graph on the second one. What's similar to what? Okay, so A, if we go A, B, C, we would have to go
Z.
A, B, C is A, B, C. We'd have to go Z, Y, X. Yeah, A, B, C, Z, Y, X. A, B, C, Z, Y, X. Okay? If you don't go A, B, C and you go C, B, A to begin with, that's fine. You would just have to go X, Y, Z or whatever, right? Okay? All right, backside. Let's answer some questions. These are going to be side angle side ones, okay? And A and B, we're just determining whether or not they give us enough information to determine side angle side, okay? So, if I look at the sides, this one is 4 and this one is 4. So we have an isosceles triangle, we have an isosceles triangle. If I do 4 over 2.5, that's obviously going to be the same as 4 over 2.5, right? So out of my side angle side, I can check off this one, this one. I have to have the angle in the middle, right? So T would have to be the same as W. Do we know that for sure? No. So no, they are not necessarily. Given what we have, given the information we have right now, we do not know that they are similar. They might be, but they don't tell us for sure that those angles are the same. So not similar. Okay. Next, this one's a little bit confusing because we have a little inside triangle, right? Okay. Ooh, we do have an angle, right? They are sharing angle A, right? They're sharing angle A, so this is shared. And if we were doing this as a proof, just as a heads up, we know that this is coming. If we were doing this as a proof, we would say angle A for the small triangle is the same as angle A for the big triangle. Do you remember what that's called? That's the reflexive property. Okay.
Proofs, aren't we?
Yep, at the end of this chapter we will. Or maybe tomorrow. I don't know. Oh, tomorrow. Woo! This is 7-4. Tomorrow we're taking a mid-chapter quiz.
Thanks for
Okay, so midway to the chapter, Evan, we take a mid-chapter quiz. And it's just like a 10-question quiz. You don't have any homework afterward. It's just it's basically like an assignment that you do in class because you can use your notes on it. So it's not really any big deal. That's not really any big deal.
And
Libby just puts too much stress on it because she's like, I have to check my answers 7 times.
And we also
Oh my
talk
goodness.
sometimes during it. So
Oh
you
my
can get
goodness.
some free
answers.
We definitely
Uh,
We're not supposed to though. Only one.
Whatever.
It's
Okay.
not like that many questions.
Whatever.
No, it's
All
only
right,
like
here we
every
go.
once in a while.
So we have our angle. So side, angle, side. We have checked off the angle. He is good to go. Sides. What's let's do some sides here. What over what?
8
8 over.
12.
It has to be the whole side. So 12 equals 10 over 15. Okay, so we could either cross multiply or we can reduce. 8 over 12 is, if you divide by 4, that's 2/3. Or 0.6 repeating. 10 over 15, if you divide by 5, that is also 2/3. Check. Side and side checked off, so yes.
Swag.
Triangle whatever is similar to triangle whatever. What do we got? How do you want to name him?
Okay. Triangle AFE.
AFE, okay. And A,
Similar to
ABC, sure. AFE, ABC. That'll work. Okay.
No graph.
No graph, but we're gonna do the bottom one. The bottom one, we'll do that stereotypical, whatever. Not stereotypical, but typical. The typical shadow tree thing, okay? Take a look at your person. He is 5 feet 9 inches. Did I yell real loud yesterday when I said that? 5 feet 9 inches is not 5.9 feet. No. We go 5 and 9 out of 12. What's 9 out of 12?
3/4.
3/4, which is 0.75. So on the diagram, they have correctly labeled it as 5.75. So just FYI, that's where he comes from. And let's do our proportion. We're trying to figure out how tall the tree is. They have labeled that as H. Okay, so what would you like to do?
5.7.
Sure, 5.75 over 12. Okay, sure.
Equal to. And then
H over,
No,
not 5.2.
It's the whole thing.
The whole thing will be
17.5.
17.2. Yeah. Okay, and they were kind of tricky. 12H, I can do that. I think that comes out to be 120. No, I don't know. 120 maybe?
This is crayon just train my brain to do
98.9.
What?
98.
Oh, 98.9. Yeah, that's right.
And divided by 12.
98.9? Yeah. Yeah, okay. Yeah.
Whoa. 8.24.
Divide by 12. The height is 8.24 foot.
Wait.
Foot. There you go.
Oh shoot.
Okay, good?
Good.
Happy with that? Okay. On the homework. All on practice. All on practice. 7 problems. They shouldn't be too bad. Make sure on 3, 4, 5, 6 you plug back in because they're asking for like the sides like FG, PRSR, BECE, JLLK. Make sure you're plugging those back in. And then we have odds on the back side. Okay? Skills practice is odds. Skills practice is odds. So 11 problems, I think.
Yeah.
So anyway. All right, happy with that?
Yep.
Okay, bye, Jalen.
Bye.